All right, in this video, we're going to be sketching a parabola, and I'm going to be taking you through the key features that you need to be able to label in order to, adequately sketch and demonstrate your ability to sketch a parabola. The things we're going to need are the x-intercepts, the y-intercept, singular, and the turning point of that function. And if we can, along the way, we'll grab that axis of symmetry as well. So, my parabola in question today is y equals minus 2x squared minus 4x plus 6. And a couple of things to note straight off the bat. We don't have to think too far for the y-intercept because it's right here in the general form of a quadratic equation. This term at the end here, this 6, is the y-intercept. So straight away I can identify a key piece of information. And furthermore, I can just keep in the back of my mind the fact that this parabola is going to be negative. The coefficient of x squared is negative, and hence it's going to be a downward shape or a sad face. And it's by a factor of 2 as well, so it's going to be a bit thinner than a regular parabola. Okay, but further information such as the x-intercept or the turning point, we're going to need to manipulate this somewhat. So first thing I'm going to be doing is looking at this and realizing that in order to factorize this quadratic to get the x-intercepts, it might be easier to just factor out this minus 2, and that will turn my quadratic into a monic, which I can solve much easier. So I'm going to take a factor of negative 2 out of all of these terms and get y equals minus 2 times x squared, factorize minus 2 out of that, and I get plus 2x. And then lastly, I'm going to factorize minus 2 and get minus 3. Okay, now I have a monic quadratic. Now, if that's not possible, or rather it doesn't help you, say for example this was a 7 at the end, which doesn't have a nice factor of minus 2 in it, you would have to apply a different factorization technique where you multiply a and c together and then so on. However, for me, I could identify that all three coefficients, a, b, and c, all had a factor of negative 2, so I can factorize that out. Now looking here, I apply my typical monic quadratic factorization skill and I say, are there two numbers that multiply to negative 3 and add to 2? Well, if they're going to multiply to negative 3, they have to have one has to be negative, one has to be positive. And I can see that there is only one pair of factors that multiply to 3, as it is prime, and that is 1 and 3. And if I have positive 3 and negative 1, they multiply to negative 3, but also positive 3 and negative 1 add to positive 2. So I do in fact have those factors, and I can say y is equal to minus 2 times by x, positive 3 minus 1. So x plus 3 and x take away 1. And that will expand out nicely into this, and then I can re-expand it into my original equation. So from here, what's the point? Well, of course, the point is to get these pair of brackets, which helps me identify those x-intercepts, because x-intercepts occur when y equals 0. So if I made this 0, this whole left-hand side of the equation is 0, meaning I need to find values of x which make the right-hand side 0, otherwise they're not equal. And it's very easy in this form to determine those values that make the right-hand side 0, because if either bracket becomes 0, either one, then this whole thing becomes 0, because say this is 0, 0 times a number is 0, or if this one's 0, a number times 0 is 0, and then minus 2 times 0 is just 0. So I can find two numbers here. It's quite straightforward, and I'm going to use green to determine that. I've used blue for the y-intercept, I'll use blue again. X is going to equal here negative 3, and x is going to equal positive 1. Because if I sub negative 3 in, I get minus 3 plus 3 is 0, the whole thing wipes to 0. If I sub x equals 1 in, I get 1 minus 1 is 0, the whole thing wipes to 0. So these are my x-intercepts, minus 3 and 1. To go along with my y-intercept, and I'm getting very close to finalizing this problem, being able to sketch it down here. So I've got my y-intercept, I've got my x-intercepts. What I need now is the turning point of this guy. Now I have the option. I could, of course, complete the square in here and turn it into turning point form and read it off. However, I've done that in another video, and if you'd like to, that's a more than valid strategy. An alternate method is to find the axis of symmetry and then sub it back into the equation. So you'll find the x value for the axis of symmetry, sub it in to find the y value, and that's going to be your turning point. I'm going to need more space for that though, so I'm going to take these x-intercepts, put them over here where I can remember them, and then use this space to determine that axis of symmetry. Alrighty, so I've popped my x-intercepts over here so I can remember them. Over here I'm going to find the axis of symmetry. Now the axis of symmetry comes from minus b over 2a. I'll just write that up here. Axis of symmetry is minus b over 2a. And that's the axis of symmetry for the x coordinate. So really I'm going to be writing underneath here x equals minus b over 2a for my axis of symmetry. Minus b and 2a, well rather b and a, what are they? Well of course, just as a reminder, a is the coefficient of x squared, so in this case it's going to be negative 2, and b is the coefficient of the linear x, which is negative 4 in my original equation, and hence I'm going to say x is equal to minus, and then I put in b, which is minus 4, over 2a, so that's going to be 2 lots of negative 2. Okay, so simplifying now, x is going to be equal to negative 4 is just 4, over 2 times negative 2 is negative 4, which is going to simplify to negative 1. So in line with x equals negative 1, that straight vertical line, that is going to be the axis of symmetry, and I now substitute x equals negative 1 into my original equation to determine the y value of that turning point. So I'm going to do this just below. I'm going to say y is going to equal negative 2 times x. Now x is going to be this negative 1 squared, minus 4 times negative 1 plus 6. Simplifying that, I get negative 1 squared, because of course BODMAS still applies. We do orders before we do multiplication. So negative 1 squared is 1, minus 2 times 1 is just negative 2. I've got minus 4 times minus 1 now, which is plus 4, and I have plus 6 at the end. 4 and 6 is 10, minus 2, y is equal to 8. And hence, I might just write that over here, hence the turning point is at the point negative 1, 8. And I have now found my turning point, my y-intercept, and my x-intercepts, and I'm finally ready to sketch, which I was going to do here, but I might wipe this and put it here. So I've got my Cartesian coordinate system set up. I just need to translate this information onto this graph now. So I'm going to use my red pen for nice contrast, and I'm going to say, first of all, the y-intercept was 6. So if I go up 1, 2, 3, 4, 5, 6 to here, that point there is going to be the y-intercept. I also have x-intercepts at 1 and minus 3, so 1, that's an x-intercept, and minus 3, 1, 2, 3 in the negative direction, that's another intercept. And the last thing I need to plot is my turning point at minus 1. Sorry, I'll label that. Negative 1, that's the axis of symmetry, and it goes up to 7, 8. So right there, I'll put a dot this time, is going to be my turning point, and now it's just a matter of connecting the dots. So from my turning point, I'm going to go through my y-intercept and down through my x-axis intercept here and straight down like that off to negative infinity. And from the turning point, I'm also going to head symmetrically down to this x-intercept and then off towards negative infinity as well. The key part is here I'm going to be labeling this as negative 1, 8 for my turning point. I'm going to be labeling this as minus 3, 0. I'm going to be labeling this as 1, 0. I'm going to be labeling this as 0, 6. And I have labeled now all 4 key points in a parabola. You always are going to have a y-intercept somewhere. You are always going to have a turning point somewhere. And you are either going to have 0, 1, or 2 x-intercepts. And if you have 1 or 2, those should be labeled as well. So in for example, a non-calculator test, you would need to show all of these features on the graph, and potentially in a calculator test you would need to show those features as well. So get in the habit of putting them on there. And the last thing I'll do is I'm going to write my equation, y equals minus 2x squared minus 4x plus 6 as the graph that I have, or rather the equation that I have graphed. So that's the process. If you need to sketch a parabola of any sort, you're going to need your x-intercept, your y-intercept, and your turning point. Hope that helped.